Einstein's Relativity, the Special Theory and the General Theory. Chapter 4. The Inertial Frame of Reference. As many of the readers of this book should be familiar, one of the fundamental principles of Galileo Newtonian mechanics, generally known as Galileo's law of inertia, can be stated as follows. Given a body that is sufficiently distant from other bodies, it remains in the state of rest if it is in the state of rest, or it continues its uniform motion in a straight line otherwise. This principle, which is also known as Newton's first law of motion, is generally understood as describing the natural state of the motion of a free body in mechanics. But in addition, it also says something about the particular bodies of reference, or frames of reference, that are permissible in mechanics. That is to say, the law of inertia can also be viewed essentially as a criterion of specifying which particular frames of reference could be used in the description of mechanics. Let's quickly see why that is. The visible fixed stars, for instance, can be certainly regarded as the bodies to which the law of inertia apply to a high degree of approximation. Now, if we use a frame of reference that is rigidly attached to the Earth, then relative to this frame of reference, every fixed star traces a circle of an enormous radius, and not a straight line in the course of an astronomical day. This is clearly inconsistent with the statement of the law of inertia. We can easily see from this example, therefore, that the law of inertia is not universally applicable. It does not hold true, at least in one example, that is, with respect to the reference frames which are stationary relative to the spinning Earth.